Good afternoon, everyone. Our last session will be presented by Dr. Maja Djolic and Professor Alexander Marinkovic, who work together at the University of Belgrade in Serbia. I have some collaborations with Maja, and I'm very sorry that she could not attend today. I have also the pleasure to meet Professor Alexander and start a new collaboration with him, who is a top expert in his field. So Alexander, is also a pleasure to meet you again, unfortunately, virtually. So the main fields of research of their group includes organic polymer synthesis, biosourced revalorization, materials functionalization for absorption and also catalysis, and water and wastewater treatment. So a special thanks to Alexander and Maja to join us today and share with us your great work. So Maja, the floor is yours, please.
Thank you, Rita. Thank you all. It's a really pleasure.
Unmute, no?
Can you hear me?
We cannot hear you.
Yes, we can hear you.
You can hear me?
Yes. Yes, we can hear you.
Thank you. Thank you all. Thank you, Rita.
Okay.
It's a real pleasure to be today with you, although remotely. And I would like to thank also to Dr. Kaloudis for this opportunity to present what we are doing here in University of Belgrade. And also thanks to Gianluca Lipuma. He was so inspiring as always. So let's see what we are doing actually. The title of our presentation is Natural Polymers as a Separation Medium for Removal of Taste and Odor Causing Compounds. We are working a lot with biomaterials, and as you know, they are widely spread, and the application of those materials here really present in environmental and chemical engineering, also in material science, as well as in some biomaterial applications. So it's something that is all around near to us. It comes from the nature and it is extracted from the plants and animals, but we can find various applications for those kind of materials, and that is actually the main scope of the field, Professor Marinkovic and his team. And now, why natural polymers? Actually, it is the most of the time waste byproducts from the pulp of paper industries or biomass pretreatment processes. It's not still enough exploited, so we need to find the second value, or how we used to say in material science, the new added value of some waste materials, or to find the valorization of the waste. And also there is a lot of chances to play a bit with the chemistry of the material, because as I said, it is something that derives from the nature. So each alive cell is consists of those kind of organic molecules. And the most of the time they are low in cost, they are eco-friendly, and those are just some of the benefits why we use natural polymers in material science. So the main benefit is also processing and modification. And we used to say the most of them are green because they came from nature. And there is really a wide range of possibilities to do removal of anorganic and organic contaminants, including dyes, azo dyes. And there is also disparate functionalities, because what we are doing basically here is material functionalization. So playing with the surface chemistry mostly, we can prepare material for some target pollutants or the mixture of pollutants, depending what is the starting matrix and what we want to obtain. So today you will see the most of research that has been done in the last few years within this group. And taste and odor compounds is something that we did not have experience with, but I took this publication from 1974, trying to show how old are these and how still attractive are these kind of compounds. And actually, this is the year when the Coast Association was launched as well. So those compounds, as you are all more familiar than we are, came from industrial and municipal sewage effluents, and there is a lot of reasons why should we investigate them, mostly because the high treatment cost for public water supply or the bad smell, right? And which directly reduce the aesthetic value of some water bodies, especially when they are used for recreational purposes. And starting from here, this is what we are doing. The most of compounds, what we are investigating are cellulose, lignin compounds, and wood derivatives, actually. So you will see here softwood, a lignin fragment with many hydroxyl group, which give us a lot of space for other chemistry modification. And what is our main experimental procedure, or how we close the loop going from the waste material and isolating molecule which we want, I do apologize, isolating the molecule which we want to further investigate, and then what we want to get in this specific research. It was lignin microspheres, amino-modified lignin microsphere, which were tested for some heavy metal removal, including oxyanions. And also these kind of materials were applied in the batch mode, batch reactor, as well as in a column. So this is like visual interpretation of the most of the work that we are doing, including characterization techniques, which are really various, because we have cooperation with the Institute of Nuclear Sciences in Belgrade, Vinča, also the Faculty of Chemistry, the Faculty of Pharmacy, and so on. You will see how large the group is. So those are the most well-known characterization techniques, including also Moss-Bauer, when we are doing some research with iron hydroxides as well. And also absorption, isotherm, and kinetics modeling, because we have a group from chemistry faculty which are doing this kind of modelings. And this is how we are trying to understand also the mechanism or chemism of the reaction. So we are a bit, let's say, multidisciplinary, going from the functionality, chemical modification, also to material science like surface functionalization, but also trying to understand the mechanism of reaction, and to close the loop of materials applying environmental applications and protection. As I said, this work, or this PhD study, was supervised by Professor Aleksandar Marinković, and the aim was to get lignin microspheres. You just see some of the, let's say, main chemistry, what was used here, like cross-linker, or the point was to do amino functionalization of the material. And you will see how this microsphere had a very smooth surface, and also really, let's say, good shape, round shape. So we used to say that we also, by choosing the right chemical agents, we are doing material design. Actually, the point was to obtain also high porosity of the materials, so they can be applied in some column studies as well as batch application. And here you see how they are really precisely modeled. But when I say modeled, I don't mean on IT, I mean like choosing the right chemistry. So as I said, we were testing these kind of materials for heavy metals, oxyanions, but also for organic pollutants. One was diclofenac as well. And here I want to show that we are also doing theoretical chemistry and this part of modeling. what you see is molecule of the diclofenac. And we are doing some kind of calculations, let's say, in terms of the most highest probability, how the interactions or electrostatic bonding will take place among various molecules. And this was also published. Actually, everything what you can see now or today is published in 2020 or 2021. And actually, from this work, what we got is eco-friendly, cost-efficient, and really effective adsorption materials with the porous structure. And the aim was to test it for anorganic and organic pollutants. So we are now doing some kind of simultaneous removal, or the goal was to try to see in real matrices how it will react and affect the real pollutants. Also, what was done and published as well is that this kind of material may be applied as immobilizer or carrier for biocatalysis or enzymes immobilization. So this was also done with the colleagues from biological department of the Faculty of Technology and Metallurgy, biochemistry. And yes, next you will see some kind of hybrid materials that were actually some mixture of cellulose, lignin, and hemicellulose, as those are actually the main agricultural waste derivatives. And here you can see some of percents, how they are present in the nature, but also if we say that those are the main components of agricultural waste, you can actually understand the real value that those are actually compounds that are available and very abundant, and we are trying to find the real application of those. So this study was related to the mixture of lignin, which you just saw one of possible routes of transformation. Actually, here is epoxy lignin, but also cellulose and tannic acid. And this work was also one of PhD studies supervised by Alexander, but I think it was applied for heavy metals and also for pesticides. And the way was to, you see how it was also performed in the final design with the molding, membrane producing, and 3 types of hybrid membrane was obtained finally. And you can see on the right from some micrograms that actually there were slight differences in the way how the fibers finally looked. And actually this is solid liquid interactions that we are trying to go, as I said, from the surface chemistry and to try to play with materials in order which are our target analytes. Sorry. Just a second. Yeah, this is one more work which was performed on waste cellulose and cellulose fibers, and also in addition with anorganic diatomate earth. It's like a zeolite. So we played with organic and anorganic matrices in order to obtain also, let's say, hybrid cellulose-based membrane. And this was also tested for pesticides. And you will see that the point was to make amino modification of the material. Okay, what we are else doing concerning the natural polymers or the types of natural polymers is starch. This work was done also as one of PhD students. And the point was to try to obtain a new way to get cationic starch in order to apply it for dual application as an adsorbent or also for a food packaging. And this may be interesting also for taste and other compounds, because if you gain to get the material which is good adsorbent but also good for this kind of compounds, then for sure it can be applied in food packaging processing. And the modificator was taken, it was a green from spinach, betaine, hydrochloride, And at the moment, it was tested for heavy metals, for oxyanions, for pesticides, and all results, also for some mineral anions, and the results were quite good. And this is also one of the studies when we try to use natural plasticizers in order to obtain biocomposites. You will see that there is a wide array of natural or nature-based plasticizers, and what is the main conclusion, that those, even they are green, they contribute to a higher compatibility of biocomposites. And this is also, as I mentioned, the way how we can tailor processing conditions, not only structural and morphological properties of the material, but also the main goal with starch is to decrease hydrophobicity, because we know that the starch likes water. So that was the problem if you want to test it as an absorbent or as a source material of food packaging as well. Here also some of examples what we have done in the field of biocomposites. You can see the addition of lignin, micro of nanolignin on the left, that significantly changed the physical-chemical properties of the material. At the first place, the structure, as well as porosity. So we have a really wide possibilities with modifications, and also in terms of future engineering application, knowing actually the chemistry of the material. And what is also ongoing research that may be interesting for some of you, we are doing plant-based adsorbents, the mixture of waste cotton fibers and miscanthus plant. That is one of the type that actually is one of PhD thesis. Also, we have done or investigated fish scale or carp shell adsorbent doped with cerium dioxide nanoparticles, also with some other organic acids for functionalization or activation of the material. And this is another PhD student. And we got a project, it's a national project where we tested craft lignin as a fireproof material. And it is, I think now we got extension of this project. So actually there were 2 projects in the similar topic. And the last but not the least, this is something that took the most of our effort. At the moment, we are trying to combine bio-based adsorption or bio-based materials, polymers, with AOP, and this synergetic effect of those. So this is our future work related to the project, which was also one of national proposals, but also one of Horizon proposals with colleagues. So we tried to enclose various disciplines in this project, starting from wastewater treatment. The target pollutants were also organics, cations, oxyanions as well, but also we were interested in waste. When the material is exhausted, what to do with this kind of waste, which kind of solidification process we need to take. Is there a leaching or not? And of course, we are also interested in process engineering, intensification, and scale up, trying to deal with industrial partners, how we can maybe perform any kind of semi-application or industrial scaling. And concerning the advanced oxidation process, this was basic proposal, let's say, about reactor. It's like a tube in tube with UV lamp in the central, but of course there are many possibilities, as you have seen from Gianluca's perfect presentation, what kind of reactors may be. And we propose peroxide process, but of course there are many possibilities in this term as well. And this is our team. Actually, just those who sent their picture are here. There are many else. The team is around 20 persons or maybe more. So we are from different faculties, but of course within the University of Belgrade, and the Faculty of Technology and Metallurgy is founded in 1967. We have 17 departments, and the main scope of research is chemistry and chemical technologies. Actually, it's applied chemistry. And we have around 300 or 400 students per year, and we are also accredited for foreign students. So we have some students from abroad. And those are our most significant achievements in the last 5 years, because we are working a lot with industrial partners, because this is the, well, let's say the main funding came from industry. So this is our publication list, more or less above 100 publications in the last 5 years, the most of them thanks to Alexander. Number of citations is around 3,000. And we have 14 international and national awards, international projects. You will see some numbers here, so maybe not so significant, but just to say that we are very eager to collaborate and work with any of you interested in this field. And this is kind of acknowledgement to the government or to the Ministry of Education and Science and Technology of Republic of Serbia. And very much grateful to you, especially to Rita and to Dr. Koloudis, I'm still reading his surname, for the chance to present our work here. And I'm really looking forward to meeting you as soon as possible in live. So thank you very much. Okay.
Maya. So any questions? Let me see. Any questions? So I have a question for you.
Okay, thanks.
So regarding the data that you have about adsorption and desorption for organic compounds, do you think any of these solvents could be interesting for sample preparation instead of treatment itself?
Can you just, are any of those materials may be applied for? I did not hear you.
For sample preparation.
Ah, you mean like an extraction medium, right?
Yeah.
Yes, of course. Yeah, of course. That is also one of the fields that we were trying to test. But I did not mention here. Yes, it is actually this kind of natural polymers of nature-based materials, maybe as well as adsorption medium and an extraction medium. So here I think was more interesting to show what can be done in this field of taste and other causing compounds, and as actually the chemistry is always where we can adapt or when we can functionalize materials to tackle the right pollutant. But yes, we were also using this kind of materials to try to use in solid phase extraction, for instance, like during the sample preparations for HPLC. Also, what I did not mention as well is that we have one international project when we test those materials as biosensing, like in terms of how to change chromatography. Maybe it's not possible, but because of the extensive preparation, sample preparation, time consumption, we tried to get some mobile devices and use this kind of materials in biosensing. But let's see how it will work next few years.
Yeah. Any other questions?
Yeah, we have a question from Tri. What is your strategy to combine adsorption and AOP? Yeah. Well, the strategy was actually because in Serbia, we have a really big problem with wastewater treatment. Actually, I think Belgrade is the only capital in Europe that we do not have actually wastewater treatment plant for the city. Everything what we use goes to rivers, and then we have simple chlorination and so on. So we were trying to get some synergetic effect to see is it possible to combine biosorption when it's possible with higher concentrations, and also the AOP when we have low concentrations of contaminants of emergent concern. And this is really something that is in pilot stage, but you know, at the moment we have, let's say, all parameters that this can work, but let's see how it will be implemented. The limitation is actually that cannot be implemented on the national level, like a complementary wastewater treatment technique, as we don't have wastewater treatment plant, but on regional or on global impact, it can be adopted to some more advanced, let's say, advanced countries. So this is something that we will start working on in next few months in January 22. So anyone interesting to join this project is welcome. Yeah. Thanks. Thank you.
Any other questions? No questions? Okay, Maya, I think we don't have any further question. So
Thank you, Rita.
very
Thanks.
much for joining us today. It was a pleasure to meet you again.
It was a real pleasure. And as I said, hope to see you, some of you, quite soon in live.
For sure. Yeah.
Yeah.
Thank you.
Thank you.